right, this is packet C. And this first page is all really easy stuff. You can see it's Algebra 1 skills. And so hopefully all this is pretty easy. We're going to start right here. 8% of 60 is 1/5 of what number? Ladies and gentlemen, that is a really simple math statement. It's all math. Do you have a question? You think it's A? Huh, interesting. So 8% of 60. Ladies and gentlemen, what's 10% of 60? 6. Hey, good. I love that you can answer that question, okay? 10% of 60 is 6. 8% is going to be more or less than 6? Okay. So this is a mathematical statement, and if I wanted to write 8% of 60, all I actually have to do is 8% of 60 times 60. You can see if you were to try that in your calculator, 0.08 times 60 is less than 6, okay? So just by the nature of knowing what 10% of something is, gives you a rough estimate, right, of what the value should be. So even if you didn't remember that 8% of 60 is 8% times 60, you could figure it out. If you try 0.08 divided by 60, well, that's really weird. That ain't right. Okay? If you did 8 times 60, that ain't right. If you did 0.8 times 60, you know, that ain't right either. So it must be 0.08 times 60, which is a number less than 6. Okay? So when in doubt, do some guessing and checking on your calculator. Okay? And that's really helpful. Mathematically speaking, what is in math? Equals. Okay. Here again, 1/5 of what number? There's another multiplication statement. Of means multiply. 1/5 of, well, what's what number in algebra speak? X. Okay. And so this is just a mathematical statement. And we know this is 0.48 equals 1/5 x. How do you get x by itself? Divide by 1/5. I like that better. Multiply by the reciprocal. I'm going to multiply both sides by 5/1 so that the x is by itself. And so if I multiply that by 5, I get 24. So the correct answer would be C. Not quite it. Okay. So a lot of those translate quite easily to math. Algebra, if you will. All right, let's look down the page at number 15. Now, this is part of a multi-step question. So using the information to answer the questions 13 through 15. And so this paragraph is necessary for 13, 14, and 15. It's a multi-part question. And so it says, a poll of 200 registered voters was taken before the election. This is important. There were 200 registered voters. And for mayor of Springdale, all 200 voters indicated which one of 4 candidates they would vote for. The results are given in the table below. And then you can imagine these first few questions, but we're going to go down to 15. If the information in the table were converted into a circle graph or pie chart. So just to refresh your memory, there's a circle, and we're breaking up these 4 voters into proportional size pieces of the pie, if you will, okay? And we want to know the central angle of the sector for Gomez would measure how many degrees. And so there's 2 important parts that we're reading here. First of all, when we look at the table, Gomez got what percentage of the votes? How do you figure that out? Okay, so we know that there were 200 voters, and he got, or Gomez, he or she, I don't know if it's a male term. Okay, how do you figure out what percentage? Is it 200 divided by 40? Or is it 40 out of 200? It's 40 out of 200, okay? It is, we're doing a percentage. It is a part out of the whole, okay? I'm sorry, you can't see that. Part out of the whole. The whole being the 200 people that they polled, okay? And the part, meaning the part that Gomez got, the 40 people. When you do 40 out of 200, we get 0.2. 20%. There it is. And then, so he should have, or Gomez, I keep saying he, Gomez, should have 20% of the pie, okay? So how do you figure out how many degrees that would be? Well, ladies and gentlemen, how many degrees are in a circle? 360. So we want that 0.2 of 360 degrees. That's it. So times 360, we get 72 degrees of the pie chart. Okay, pretty simple. Okay. All right, questions on that? Yeah.
I kind of thought of it differently. I just thought the whole pie is 200, and I thought each, like if you go 9 degrees, it'd be 50 people. Because
Sure.
then it's, it's a little under 90.
Okay, that's interesting. I like that. Very good. I should probably say that for the video. So say it one more time. You said you were thinking.
The whole pie is 200 people.
So 200 people must fill up this entire pie.
And if you cut in 1/4, it's 50.
And so if you cut those 200 votes into quarters, then each quarter would be 50 votes.
And it's just a little under that 90 degree, which is that quarter.
Yeah, and so we only had 40 votes, so we should have less than that quarter. So less than the 90 would be 72. That's a pretty reasonable way to arrive at a pretty good guess, okay, without any math, just reasoning, just logic. So that's really, really good, okay? I like that. Okay, we're going to turn the page to page numbered 3. Page numbered 3, briefly. And that's what a lot of these questions are. They're really just good logic on the ACT. And that's why I really like the question. This is actually math that, like, there's a problem on the page 2, this miles per gallon. My husband actually did that in real life when we got our flex fuel vehicle back when that was a thing. He's like, I just don't know, what's my price per gallon I need in order to make it, better to use the flex fuel instead of regular gasoline. Anyway, so it was real math. All right, and number 25, that's a nice sound there in the figure below. A triangle ABC is similar to triangle KLM. What does that mean when two triangles or two figures, two polygons, are similar? Same angles. Yes, that's true. The angles match. So angle A is congruent to angle K. So the measure of angle A is congruent to the measure of angle K. But, angle B is congruent to angle L. This is true as well. And angle C is congruent to angle M. Those are also congruent. But it's clear that the triangles themselves, the side lengths, are not congruent. They are not equal. However, they are proportional. Sides are proportional. All right? And so they always will fall in the same sort of proportion, which is kind of a nice thing. The lengths are given in centimeters. What is the perimeter of triangle ABC? And you can see we only have one side length on triangle ABC. Well, it turns out, and the reason I wanted to do this one is because I wanted to remind you of this. This is something that's easily forgettable. That if we have similar shapes I'm just going to say shapes. If we have similar shapes, then the ratio of perimeters is equal to the ratio of corresponding sides. Which makes sense if you think about it. If I know that corresponding sides are proportional, and these corresponding sides are also proportional, and the third corresponding sides are also proportional, then wouldn't the perimeters also be proportional? Okay, so it kind of does make sense. And so what we can do is pretty easily set up a little proportion here using some information that they gave us. So in our little triangle ABC, we have this corresponding side of length 3. What's its corresponding side? In the other figure, 7.5. So the ratio of those corresponding sides, so 3 to 7.5, is equal to the ratio of perimeters. So I'm trying to find the perimeter of this little triangle, so P, that's what I'm trying to figure out, to the perimeter of this figure. Well, what's the perimeter of triangle KLM? 35. How'd you get 35? Add them all together. So 12.5 plus 7.5 plus 15. We get 35. So the perimeter of that figure is 35. And how do you solve a proportion? Cross multiply. Get rid of those denominators by multiplying. 3 times 35 is 185. And 7.5 times P is 7.5P. And then we could divide, again, redivide by 7.5. So divide by 7.5. Oh, 105. That's weird.
It's 105,
Not, yep, thank you. I totally read that wrong. 105, not 185. Divided by 7.5 is 14. So the perimeter of this little triangle is 14. Thank you. That's an interesting shape there. I don't know what letter that is, but it was supposed to be a P. There we go. Beautiful. So a lot on geometry, congruence, and similarity here. We can turn the page to page 4. And here we're dealing with parallel lines and bisectors, so some more good math here. Math that I love. We're going to look here at number 5. Ray PK bisects angle LPM. So again, I think a picture is worth 1,000 words. So LPM is an angle. All right, so there's my angle LPM. And then ray PK bisects it. It starts at P and passes through the point K, and it's a ray, so it continues on in one direction. And what does bisect mean? To what? Bisect means there are two equal pieces, two equal angles. They are the same size. The measure of angle LPM, that is the measure of the entire thing. The whole arc here has a measure of 11x degrees. That entire arc. And the measure of angle LPK, that's just this smaller part, is 4x plus 18 degrees. Okay? LPK, that's just this smaller part. Well, what's KPM then? It's the same thing. It must be, because these two things are equal. So there must be, KPM must also be 4x plus 18 degrees. Okay? And if we add these two things together, what should it equal? 11x. The whole thing is 11x. So 2 of these 4x plus 18s must equal the 11 x. All right, so we get 2 times 4, 8 x's. 2 times 18 is 36. And that equals 11x. And then what can we do? Subtract 8x. Yep, so we would have 3x's equals 36. And then we can divide by 3, and we get x equals 12. Now, there's that answer. But we just solved for x, and they want to know what is the measure of angle KPM. Is 12 the measure of angle KPM? No, it is not. Angle KPM is 4x plus 18 degrees. So what do we need to do to actually figure out how many degrees it is? Yeah, we actually have to plug in the 12. So one more step is the name of the game. And they're going to have that answer. And again, what are they testing? How well you read. Okay, not the math. This is how well you read. All right, they didn't want you to solve for x despite the fact that the answer is there. Okay, so 4 times 12 plus 18, 48 plus 18 is 66. So that'd be 66 degrees, which is the correct answer. So please make sure that you're answering the question that is asked. Okay? All right, I want to go to the top of the page and to number 2. Funny, I renumbered this one. Oh, well, that's okay. And here we're dealing with parallel lines, so I thought this was a good question to just remind us of what happens when we have parallel lines. In the figure below, line L is parallel to line M, so I'm going to give them 2 little triangle. I don't know how your geometry teacher told you to mark parallel lines, so we did it with little arrows. Line L is parallel to line M. Transversal T and U intersect at point A and B and C respectively with line M. Point X is on M. The measure of angle ACX is 130 degrees. And the measure of BAC is 80 degrees. The question is, how many of the angles formed by angle LMT and U, not by angle, by rays LMT and U, by all the lines there, have measures of 50 degrees? So looking at this entire figure, how many angles have measures of 50 degrees? All right. When you have parallel lines cut by a transversal, which is just a line that's crossing them, okay, what sort of things happen? We get lots of congruent angles, and we get lots of supplementary angles. What's supplementary mean? Yeah, they add to be 180 degrees. So we get lots of congruent angles and supplementary angles if we have parallel lines, okay? And so, because line L and line M are parallel, I have this angle ACX that's measured 130. What's this angle where I put the dot? 50. How'd you get 50?
180 minus 130.
Yeah, we have a straight angle here that measures 180 degrees, and part of it's 130, so 180 minus the 130, whoops, you can't see that. There we go, is 50. So there's a 50-degree angle right there, okay? So there's one, okay. Now if that's 50 degrees, what's this angle right here? 130. How do you know it's 130? That's vertical angles right here. Scissor angles, those are always congruent. Okay. Which means what's this angle right here? 50 as well. Okay. Hey, look, a triangle with 80 and 50. What's this angle? 50 as well. How come? Yeah, because 50 plus 50 plus 80 is 180 degrees, and we know that that's the measure of angles in a triangle. Okay. All right. Where else is 50? Yeah, this vertical angle is also 50 right there. Okay. Now we have to think in terms of parallel lines. Let's see. So yeah, 50 is like right here. Right here, 50 degrees. Why is this angle also 50 degrees? Oh, yeah. So here's a straight angle of 180 degrees. A piece is 50, a piece is 80. This also must be 50 degrees. That's true. These are also corresponding angles right here. These, because of parallel lines, these are corresponding angles and they're congruent in their same corresponding position. Let's see. And then above here, look at, we've got more vertical angle pairs. This is also 50 degrees. And this vertical angle is also 50 degrees. There's a billion 50 degrees in here that you can figure out a number of different ways. Okay? So vertical angles are congruent. That's when you have two intersecting lines. Angle A and angle A are congruent, and B are congruent. But when you have parallel lines, then lots of angles happen to be congruent. These are corresponding angles are congruent. These are also congruent. You get supplementary angles as well. But we have 1, 2, 3, 4, 5, 6, 7, 8 angles that measure 50 degrees. Okay? Lots going on there. All right, any questions on those? Okay. Turn the page really fast. We're just remembering. This is equations of lines. And so what is slope? That's slope-intercept form. What is the equation for slope? y2 minus y1 over x2 minus x1. Or rise over run. Okay, that's important to remember. Y's on top. Rise with the y's. The y's go on top. Y equals mx plus b is good to know. Slope-intercept form. This is the y-intercept, and here we have the slope is m, the number in front of x. And tell me about parallel lines. Parallel lines have what kinds of slopes? Parallel lines have equal slopes, or the same slopes. Equal slopes. Very good. Okay, that's all I wanted to talk about there. And then number 55. And this is one of those ones that seems hard-ish, but really isn't. For some real number a, the graph of the line y equals the quantity a plus 1 times x plus 8 is in the standard xy coordinate plane and passes through the point 2, 6. What is the slope of this line? If they want the slope, we need to know what is the number in front of the x. So our job is to figure out this number in front of x, which is a little bit weird looking. Okay. But they gave us a point. Ladies and gentlemen, when they give you a point in an xy coordinate plane, what information are they giving you? An x and a y. They are absolutely giving you an x and a y. And if I have an equation, what can I do with these numbers? Plug them in, absolutely. So instead of y, we are going to use a 6. And then a plus 1. And instead of an x, we have a 2 plus 8. And from there, we can just clean it up. Let's see. What can we do with this times by 2? Distribute it, sure. So let's distribute that 2. So we get 6 equals 2a plus 2 plus 8. That would be 6 equals 2a plus 10. And then this allows us to solve for a. How can we solve for a? Subtract 10. Subtract 10, that gives me negative 4 equals 2a. And then we can divide by 2, so we get a equals negative 2. All right, is that the slope? No. We're going to take that value and plug it back in to that equation they gave us. Y equals negative 2 plus 1 times x plus 8. Negative 2 plus 1 is negative 1. Ladies and gentlemen, this is y equals mx plus b form. What's the slope? Yeah, the slope is negative 1. Okay? So pretty easy to figure out. Plug in what you know. When in doubt, plug stuff in, right? I give you an x and a y, plug it in for x and y, okay? Very, very good. I have one more. Uno más, number 5 on the last page. Number 5, in the figure below, 2 non-adjacent sides of a regular pentagon, 5 congruent sides and 5 congruent angles, are extended. So these are the sides that are being extended here until they meet at point X. What is the measure of angle X? So we're trying to figure out how many degrees are in that little angle right there at angle X. And if I knew what the measure of these interior angles were on that pentagon, then that would be pretty easy. They're all the same measure. That's what they told us. A regular pentagon has 5 congruent sides and 5 congruent interior angles. Does anyone remember from geometry how many degrees each interior angle has in a regular pentagon? 36. Nope. First of all, even just looking at the picture, those angles look way bigger than 36 degrees, right? 720.
360?
Yeah, right? You don't know, right? That's why I chose this problem, because I couldn't remember either, okay? So, let's go with what we know. Ladies and gentlemen, how many degrees are on the interior angles of a triangle? 180 degrees, and you know that, right? Okay. Watch this. I can take a quadrilateral, 4-sided figure, and geometry is all about breaking figures up into easily recognizable shapes like triangles and rectangles. That's it. That's all it is, okay? I can take any 4-sided figure and slice it into what? 2 triangles. Okay, how many degrees are in this triangle? 180. And how many degrees are in this triangle? 180. How many degrees are in a quadrilateral? 360 degrees. So then I can also take a pentagon, 1, 2, 3, 4, 5, and do the same thing. I can slice it up into triangles. So I'm going to pick a vertex, and look, there's 180 degrees, and here's another 180 degrees, and there's another 180 degrees. So how many degrees are in a pentagon? 180 times 3, 540 degrees. What? Wow? Did you say wow? Yeah, wow, right? That's 540. Okay. And so this is how you figure out how many degrees are in any shape. So I could go to a hexagon. 1, 2, 3, 4, 5, 6. And I can slice it up into a bunch of triangles. 1, 2, 3, 4 triangles. That's 180 times 4, which is 720 degrees. Do you have to memorize how many degrees are in a heptagon? No, is it pretty easy to figure out once you know how? Yes, okay. So, on a pentagon, we have 540 degrees. In a regular pentagon, we have 540 degrees divided by 5 congruent angles, which means Each angle is 108 degrees. And again, would anyone ever memorize that? No. No one memorizes that. Okay? So you have to be able to figure it out. And that's why I wanted to do this problem, because this is neat. Okay? That's where it comes from. It's not hard, it's logic. Okay. All right, if I know that this is 108 degrees, what is its supplementary angles going to be? How do you get that? 180 minus 108. Okay. So these angles are 72 degrees right there and right there. And if we know that those are both 72 degrees, then we can get our third angle in that little triangle by subtracting from 180. 180 minus the 72 minus the other 72, and we get that angle X is 36 degrees. Okay? Ladies and gentlemen, geometry is so cool. When it's done right. Okay. This kind of stuff is amazing to me. That's it, ladies and gentlemen. Please finish this packet, get those others done, and turn them into the orange bin when you're finished. Thank you very much.